All right, so I'll be reviewing Wednesday's May 20th assignment on Gay-Lussac's Law, Part 2. Up here we have Gay-Lussac law, where we have the initial pressure divided by the initial temperature equals the final pressure divided by the final temperature. Number 1, if the pressure of the gas is at constant volume is 3.5 atmospheres at 100 degrees Celsius, what would the pressure be? We don't know what the pressure would be if the temperature is changed to 250 degrees Celsius. Okay, so again, we have to add 273 to convert the temperature to Kelvin. The reason why we change it to Kelvin is because we don't want any negative values in the gas laws, because we could have negative 5 degrees Celsius and then our answer in the end is going to be negative, and we can't have any negatives. So that's why we have to convert it into Kelvin. So now T1 is actually going to be 373 Kelvin and T2 is actually 523 Kelvin, right? So we're going to plug it into our formula. 3.5 divided by 373 equals X divided by 523. You do your math, you'll find that X, which is the final pressure, is equal to 4.9 atmospheres. Okay. Moving on to number 2. So we have a volume, 800 milliliters of helium gas, is at 55 degrees Celsius at 0.344 atmospheres. So this volume is constant, so we don't need it. So we have our temperature. They said T1 is 55 degrees Celsius, and P1, the pressure, is 0.344 atmospheres. The question says, what would the pressure be? What would the pressure be? So P2, we don't know, X. If the temperature changes to 100 degrees Celsius. Oh, wow, there's a typo. If the volume remains the same. Okay, so I'm going to add 273 because we have to convert this to Kelvin. So the new T1 value is going to be 328 Kelvin. The new temperature over here is going to be 373 Kelvin. Put it into the formula. Cross multiply, and then you will find that X is equal to 0.39. You could round that to 0.4 if you want. Don't forget your units. We're solving for pressure, and the pressure was in the units of atmospheres. Okay, so that's number 2. Moving on to number 3. A container of gas is initially at 0.5 atmospheres. So the pressure initially, P1, is at 0.5 atmospheres at 25 degrees Celsius. What would the pressure be? What would the pressure be, P2, if the temperature rises to 125 degrees Celsius? Convert Celsius to Kelvin by adding 273. So now our new T1 will be 298 Kelvin, and then T2 will be 398 Kelvin. Put it into the formula. Divided by 298, don't forget your units, equals X over 398K. cross multiply, and you'll find that as your temperature increases, your pressure also increases, and it increased to 0.67 atmospheres. You could round that to 0.7 if you like, and this was P2. This is number 3. Next and last number 4. So a gas thermometer measures temperature by measuring the pressure of a gas inside the fixed volume container. The thermometer reads a pressure, so P1, of 248 kilopascals. And it was at a temperature of 0 degrees Celsius. A lot of you messed up on here as well. I put 0 into the formula when you know that's not going to work out. Your answer will be 0. And this is why we have to change Celsius into Kelvin, because you won't have those numbers. Now the pressure, the second pressure will be 345 kilopascals. And now they want to know what temperature will that be at. So we have to add 273 because we cannot have 0, because you put 0, your answer is going to be 0. So T1 is going to be 273 Kelvin. Now we put that into our formula. And we'll find that our final temperature, T2, equals 379.7 Kelvin. You could round that number to 380 Kelvin. And that is the final answer. All right, so I just reviewed Wednesday assignment 1, 2, 3, and 4. If you did not receive full credit, please go over, send me your corrections to get full credit. Don't miss out on this 100. All right. Any questions, send me a message on Jupiter.